Hey everyone, welcome back to my math tutoring channel where I will be doing tutoring videos, in this case for calculus. Today we're looking at the product rule, which is an integral part of derivatives. So the product rule is how you would use this rule to find the derivative between two different functions. And these functions they cannot necessarily be multiplied to make one simpler function. For example, if you have x cubed multiplied by x squared, you can get x to the power of 5, and then this is easy to take the derivative of. But if you have something like x cubed times sine x, that's when this rule comes in handy. And so I think now is the right time to actually prove it to you as well. And as you can see, I have this proof pre-written. And so if you think this is unnecessary, please skip through it. If you think it's necessary, useful, or even just interesting, please stay. And then I'll explain this to you. So like with any other proof, we have a limit definition, which is just the limit of f of x plus h minus f of x all over h as h approaches 0. So we just do the same thing with this composite function of f of x multiplied by g of x. And so we have f of x plus h times g of x plus h minus f of x times g of x all over h. And so this doesn't seem like something we can really simplify further. But if we add and subtract f of x plus h multiplied by g of x on the numerator, we can split this function into f of x plus h times g of x plus h minus f of x plus h times g of x all over h as h approaches 0. And so this, after you take out the factor f of x plus h, you get this over here, which looks a lot like the limit definition of the derivative, except only difference is it's up here. And similarly, you can do the same thing with g of x. So in this other case over here, instead of g of x plus h, you have g of x. And if you were to take that as a common factor outside, you get this, which is just the limit definition. So this becomes g prime, and this becomes f prime. And I'll just use arrows to show what they become. And so now you have the limit of f of x plus h multiplied by g prime of x plus g prime of x multiplied by, plus g of x multiplied by f prime. And so now as h approaches 0, this just becomes 0. So you get f of x times the derivative of g of x plus f prime of x times the derivative of g of x. Or you can think of it as first times second prime plus first prime times second, where first and second are the two different functions that are involved in the product rule. And the product rule is commutative, so these two can be switched around and it will still work. However, not every rule is commutative, so you have to be careful. And so now that you know what the product rule is, let's get on to an actual problem. What is the derivative of x squared times sine x? Pause the video and try and solve it for yourself. Ready? So the derivative of this function is the derivative of x squared multiplied by sine x plus x squared multiplied by the derivative of sine x. And if you recall from previous videos, we have the power rule. So if you have anything like x to the power of n, you take this exponent down here and then decrease the exponent of x by 1. So that means for x squared, it would be 2x to the power of 1. And then the sine x stays the same over here. And also like in previous videos, Sine x is a function you can find the derivative of, and that becomes cosine x. And so 2 times x to the power of 1 just becomes 2x. And from here, you could factor out an x, and you get 2 sine x plus x cosine x. And so that's a product rule. 2. We'll vary it up a little, and instead of just using power functions, we'll also use like sum and difference. So say we have some function e to the power of x plus 3x minus 1, all multiplied by cosine x. What do you think the derivative will be? Pause the video and try it for yourself. Ready? Here we go. So now we take the derivative of this first function. So that means e to the power of x plus 3x minus 1, and we keep the cosine x aside for now. That's the same. And then we have this other function e to the power of x plus 3x minus 1, and then we take the derivative of cosine x. So using the sum and difference rule, we can take the derivative of these separately. So that means we can take the derivative of e to the power of x, 3x, and negative 1 separately, and it would still work. So the derivative of e to the power of x is e to the power of x, and the derivative of anything multiplied by x is just that number. So this would be 3, and a constant's derivative is 0. And so now cosine x. We remember that if you remember from any previous video that proved the derivative of cosine x, it's negative sine x. If you don't remember it, it's okay, although you should probably try and remember it, just because it's a very important derivative and it comes up a lot, especially on AP tests. And so this is your actual derivative, and from here, if you want, you can expand it so that it's e to the power of x times cosine x plus 3 cosine x minus e to the power of x times sine x minus 3x sine x plus sine x. And you could leave it like this, like bottom one over here, or you can leave it like this up here, or you could even combine a couple of like terms and get ex and whatever's inside plus 3 and then whatever's inside. You can do it however you like in that aspect. Personally, I would stick with this last one. Sorry, the last one in the sense the second one in red, not the last one that I was partially writing in blue. Now for the last question. So say we have some function f of x is equal to tangent x times cosine x. And you might be thinking, oh, how do I do that? I don't know the derivative of tangent x. And once you find out the derivative of tangent x, this function is entirely possible to differentiate. But there is a much easier way to do it. And sometimes you don't even need to use the product rule. In fact, tangent x is defined such that it is sine x divided by cosine x. So if you were to replace tangent x with sine over cosine, you get sine x over cosine x times cosine x. And so that just cancels out to become sine x. And this becomes something that's pretty easy to take the derivative for. So that means the derivative of this function is just cosine x. So the product rule isn't necessary in all cases. Just because you see two functions multiplied by each other, that doesn't always mean you have to use a product rule. Will it work? Yeah, definitely, it has to. Is it the most efficient in some cases? No. So it's up to your discretion to determine when it's efficient and when it's not. And personally, I use the product rule unless I have two of the same type of function. For example, two trig functions like that. Then I'll see if I can try to factorize it. If I have like two polynomials or two trig functions, polynomials in the sense if it's like x to the power of, like if it's a long polynomial, I might take a product rule just because I don't it will be too time consuming to actually expand it. But if it's something like x squared times x, I will just simply do x cubed and take a derivative. And that's just my 2 cents. I just normally try and factor it out or like simplify if they're the same type of function, but otherwise a product rule is fine. And even in general, if for the same types of functions, a product rule is fine, it will always work. And I recommend at the beginning actually doing that so that you get more practice with it. Thank you so much for watching and stay tuned for the next video.